Hello, my dear students. I want to answer some questions. 4 different people have texted me or emailed me or sent me messages attached to the homework one did it in the homework, one did it in the stream, about how to work the problems at the end of section 3.1. And I apologize, I have not recorded my lecture and my voiceover for the section 3.1. The only people who've heard me were the first period face to face before I got sent home to quarantine with my son. So I have a picture of our assignment right here. Don't be scared. This is from last spring. This is where we're headed. So this is a lecture topic for last semester, last year, question number 14. Let me get rid of this before anybody gets too scared. And let's work some simple math. So I've got 3 problems within question 20, and they're not asking you for anything except how many significant figures. So one of them, A, is 3.85 times 10 to the minus 3 decimeters, not a very common unit. 17.30 cubic centimeters, okay, and 0.0037 millimeters, a very short distance. How do you tell the numbers of big figures? Well, without going through the rules or reviewing the rules, let me say the easiest way to do it is to always put the value into scientific notation and count the number of digits. So this has 3 sig figs. Sorry, I started making it F when I wanted to draw my S. 3 significant figures. That's your answer. This has 4. And you might say, wait, zeros, aren't zeros to the right not significant? If they're to the right of the number but to the left of the decimal point, yes. But that's too hard of a rule to remember. I just remember this. They would not have reported that zero, if they weren't able to accurately measure it and tell the difference between 17.29, 17.30, and 17.31. So 4 sig figs for this one. Although in scientific notation, it is 1.730 times 10 to the 1. Okay? Don't forget the units, cubic centimeters. Here's another one. How many sig figs? Are these zeros significant? No, they're to the left. Even though they're to the right of the decimal point, they're to the left of our measurement. However, that's another hard rule for me to remember. Put it into scientific notation. 3.7 times 10 to the minus 1, 2, 3. Oops, sorry. 1, 2, 3, 4. So I need to go 1, 2, 3. Let's see if I start here at 3. 1, 2, 3. That's what I mean. That's where I wanted to start numbering. Times 10 to the minus 3 millimeters. And there I've got 2. So this is 2 sig figs. So there's your answers. I didn't mean to do all of them for the first one. And of course, this one is 4. So let's go to the next question. This was just really quick. Can you tell me how many sig figs? Because that tells me the degree of accuracy in a measurement. But the next one asks, perform the following operations and give the answers in standard exponential form with the correct number of significant figures. So 37.2 milliliters plus 18.0 milliliters plus 380 milliliters. And this means I simply have to add those up. I don't have my calculator with me, add those up very quickly. 380 plus 18.0 plus 37.2, and I get my answer is 435.2 milliliters. But I only have 2, 3, and 3 sig figs. And I can't have any more significant figures than my least accurate number. So, if you want to know the truth, I would write this as 440 milliliters. I rounded up because I went over the 5 here. And now I have 2 sig figs. However, you could put it to the place if you wanted to do that and say, you know, this one doesn't have anything beyond the decimal, doesn't include any tenths, and you could arguably call this 435 milliliters. I would count that right. And I also will only take off, I want you to be plus or minus 1 sig fig. For the college class, you need the correct number of sig figs. So, that's that, but that's not the question. The question is put it in proper scientific notation. So this would be 4.40 times 10 to the 2. Okay, because I moved my decimal point 2 places, milliliters. There's your answer. Okay? Now, with 2 significant figures. Let me look at the next question. I'll leave you to do the last one. I've already taken more time than I want on this video. I need to look it up. It said 0, this would be 0.57 centimeters times 0.86 centimeters times 17.1 centimeters. Okay? So I got 2, 2, and 3 sig figs. My answer cannot have more than 2. This is probably a length times width times height volume problem. So I will quickly do the math. 0.57 times 0.86 times 17.1, and this is my answer. 8.38242 centimeters times centimeters times centimeters, or cubic centimeters. This is what chemistry teachers and physics teachers call calculator vomit. Don't trust your calculator. Trust this. I can only have 2 significant figures, so this becomes 8.4 centimeters cubed. If you want to put that into scientific notation, it would be 8.4 times 10 to the 0. We don't usually do numbers between 0 and 10 in scientific notation, or actually between what, 0.1 and 10 in scientific notation. But any number raised to the 0 power is 1, of course. But this would be fine, and centimeters cubed. So you do the last one. Have a nice weekend. Hope this helped you with those questions. I'm talking fast because I want to keep the video short because it takes me forever to upload. Stay safe.